That's great. Here we go. It is time for a long, incredibly exciting review of your math test so we can prep ourselves and do fantastic on the upcoming test. So gather your thoughts. Let's get ready to rock and roll. We'll see what we can do with this pre-test here. Starting off with problem number 1, and again, please get yourself a piece of note paper, grab yourself some notes, help yourself any way you can here. Let's start with problem number 1. Robert bought a hard drive for 30% off the regular price. The sale price was blah, 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 blah. Anytime you see sale price, mark up, mark down, you should be thinking the percent box. But this is a mark up or a mark down. It's going off, so it's a percent decrease. So anytime you have percent decrease, it starts like this. Your original price minus the decrease equals the final price. And here are our percentages. Original percent is always 100. I'm taking 30% off, so that goes in the minus. And my final price is 70% of what the original price was. And this one gives me my sale price, which is the final price. It's 42 bucks. What was the original price? So we don't really need to know this part because we have the rest of what we know. So we just make a fraction out of what, equal fractions out of what we know. How much money would it be here? Over 42. Easiest, simplest way to do that is just divide these both by 10. So get rid of those zeros. 7 times what is 42? That's times 6. So 10 times 6 is 60 bucks. My original price was $60. If they ask you how much off I got, well, that would be 18 because that 60 minus 18 is 42. Boom. Number 1 is done. Moving on. Number 2, in 1 year, the student enrollment increased from that. This is an increase in percent, so believe it or not, it is another percent box, except just to mix it up for you, this time it's the original plus gives you the final number. We're not talking money, but kids. Here's my percentages, of which I only know my original percent is 100. I do not know the rest. But it increased from 560 to 588. So originally it was 560. It went to 588, which means it went up 28 students. This was an increase of what percent? So I want the percent increase right here. So again, taking what I know it's 100. I don't know the percent increase. And I know that ends up being 560 over 28. Now, I don't know about you, but as I look at this, I can reduce. If you can't reduce this, then by all means, you're going to have to multiply 100 times, do cross products, 100 times 28 divided by 560. But since 28 times 2 is 56, I could cross these things off. This becomes a 1, and 28 goes into 560 20 times. 20 times, and then it's just a matter of this. 20 times what is 100? Well, that's times 5. So multiply 1 times 5, and that's what number gets here, 5 times 1. It was a 5% increase. 5% increase. Boy, this is a fantastic test. I love this one. When a 6-foot tall fence pole casts a 10-foot shadow, a pine tree casts whatever, this is just similar triangles, people. And again, it's going to be another proportion ratio box here, but let's draw the picture first. A 6-foot tall fence pole. So here's my fence pole. It is 6 feet tall, and it casts a shadow of 10 feet. 10 feet. Cast that shadow of 10 feet. A pine tree, here's my tree, blah, 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 blah. Let's give it a little, cast a 45-foot shadow. how tall is the tree? So I want this height right here. That's my big question mark. And I don't know the stochastic. So my ratio box here, we have got the pole compared to the tree, and we are comparing its height to its shadow. So the height of the pole was 6 feet. The shadow of the pole was 10 feet. The height of the tree, I don't know, but the shadow of the tree is 45 feet. So this is what I've got to work with, which is 6/10 equals what number over 45? And once again, if you don't, well, then let's just reduce this fraction because it'll work out a little bit better. Divide them both by 2. I get 3/5, which is nice because 5 times 9 is 45, and 3 times 9 is 27 feet. The height of said tree is 27 feet. 27 feet. Wow, this has been so exciting here. Drew kept a track of the amount of time and number of pages he read each night. Does the table show direct variation? If so, give the constant of variation. If not, explain why not. Remember this, ladies and gentlemen. Okay, here's the deal. For this to be direct variation, you have to multiply this number times some number, whatever your constant of variation is. All right, that would be my k. It has to be the same number I multiply these by to get this every time. So if you ask yourself this, here's the question to ask yourself. 12 times what number equals 6? Now it doesn't really matter whether it's multiplication or division. Well, I guess it does here. Let's just do it as times. Okay, if I need to figure out what this is, if I solve this equation, 12 times what number? Remember, to solve, you do the opposite. I divide, and 6 divided by 12 is 1/2. So 12 times 1/2, or half of 12 is 6. You have to check all of these. Is half of 20 10? Yes. Is half of 16 8? Yes. Is half of 30 15? Yes. So this is, yes, it is direct variation. And what is the constant of variation? It's times 1/2 or times 0.5, however you want to say it, but it is direct variation. Number 5, use a unit multiplier to convert $12 per hour to dollars per minute. So we go $12 per hour, and I need to change the my dollars stay the same. I need to change hours to minutes. So that just means I need to use a unit multiplier to convert this. Hours are on bottom. I need to put them on top. I'm changing it into minutes. I know there's 60 minutes in 1 hour. I cross off that. I end up with 12/60, and that is dollars per minute. You need to reduce that. And believe it or not, it goes into 12 goes into 65 times. So it is this. You get a 1/5 fraction here, actually, or $1 over for every 5 minutes. No, yes, it is $1 for every 5 minutes. So how many dollars per minute it is, ladies and gentlemen? Whatever that fraction is the number you use. It's 1/5 of a dollar per minute. Now we could say, you know, 1/5 of a dollar is 20 cents per minute, but it didn't. It said to change it to dollars per minute, so it's 1/5 of a dollar per minute. Can't change it, can't help that. Solvent graph on a number line. This should be easy. Remember, we solve inequalities just like equations. You just need to subtract 4. Hopefully you know that 1 minus 4 is a -3. So x is greater than or equal to -3, which means on a number line at -3, it's a closed circle because it can be equal to it. And the numbers that are greater than number -3 go this way. Greater than -3 go to the right. Oh boy, problem number 7 is a Lulu. Hopefully you can use your paper to do this. Graph the points. Graph the points 1, -2, and 3, 2, 1, 2, 3, 1, 2, 1, -2, and 3, 2. Draw the line that extends to the points. Oh boy, this is a Lulu here, kids. Let me get a line here. Let me do this. Hold on a second. Give me 2 seconds. Do a line. Oh, it looks like it's a green line. Let's see. So I got this line that goes through here. Yours is going to look a lot nicer than mine. This is going to take a little bit of time here. So here's the deal. This is a tough one. First of all, we have to remember that slope-intercept form is like this. You have y equals mx plus b, where the letter m is the slope of the line. And that's going to be pretty easy for us to figure out, simply because, remember, slope is rise over run. So I take the line that I've drawn. I know these 2 points, so I'm going to make a triangle out of it. How high is the triangle? Well, the triangle is 1, 2, 3, 4 high. You can't hardly see that. How wide is the triangle? It's 3 wide. So it has a slope of 4/3. Now we need to figure out where the line crosses the y-axis, and that would be a lot easier if, in fact, if you drew it on a graph and a grid, it's this point right here. Now I am going to assume that that point is -3 for me. I really needed to draw that on a piece of paper, but I believe that's what will happen if I do that. So I'm going to pass on this for right now. Maybe come back to it at the end, but I want to get the rest of this done first. Number 8, a 4-foot diameter circle. Oh, let's do this. Here's my circle. It is a 4-foot diameter. It's divided into 4 congruent sectors. 4 congruent sectors, which simply means this. I cut it into these pieces. I just want the area of 1 sector in square inches. So basically, it's the area of our circle, which is pi times radius, all divided by 4. All divided by 4. So my radius, by the way, if this is a 4 diameter, it's a 2 radius. So the area is going to equal pi times 2 times 2 divided by 4. And look how nice they are, ladies and gentlemen. What do you notice here? 2 times 2 is 4. And since I have a 4 on the top and a 4 on the bottom, they cross off. My area is simply going to be whatever this pi is, which is pi. It's 3.14 inches squared. They were so nice to you. Convert 7/12 to a percent and a decimal to a percent and a decimal. No easy way around this, kids. You are going to have to do this out. You are going to have to divide 12 into 7, bottom into top, and see what you get. We'll do our decimal first and then our fraction. 12 goes into 75 times, which is 60. 12 goes into 108 times, which is 96. 12 goes into 43 times, which is 36. Oh, look, I'm going to keep getting a repeater here. because I'm just going to keep getting 40s and 36. So this 3 is going to keep repeating. So there's my decimal. That's my 0.583 is my decimal. Now the percent is a little goofy. So we did the decimal, which is the easier part of this. Here's what you have to think about. If I'm changing this to a percent, the easy part is knowing that you just move the decimal 2 places, and the percent is 58. Okay, but generally we don't like to leave 0.3 repeater decimal, a decimal 0.3 repeater in our percent. So you just have to know what is 0.3 as a fraction, and you should know that it is a third. Your percent is 58 and 1/3 percent. 58 and 1/3 percent. What you would have got, by the way, if you look down here when we were doing this, after I got to the 8 here, and I subtracted, I had a 4 down here. If I would have made the fraction instead of continuing on with my decimal, and I would have made this a fraction by putting the 4 over 12, I would have got my 1/3 as my fraction. So it is 58 and 1/3 percent. 58 and 1/3 percent. All right, here we go, ladies and gentlemen. We are almost halfway through. Number 10, and again, this is why you guys have notes, because you'll easily be able to do this. You know, this is sketch the 30, 60, 90 triangle. This one you would have in your notes, and since I let you use notes, you'll be able to easily have it there. Remember, the ratios are this. The ratio is 1 of the length of the shortest to the longest sides. Well, if you have your ratio box, remember this was 1, this was 2, and I believe this was the square root of 3. You know, the shortest side is a 1, and the longest side is a 2. So the ratio of the shortest to longest side is 1 to 2, 1/2. Number 11, Tina wants to wrap a box. What's the minimum amount of wrapping paper needed to cover all 6 sides of the faces of the box? You just have to know that is surface area. Surface area. And that is area of all sides. And just remember, you have a front, a back, a right side, a left side, a top, and a bottom. The front, right here, look at how nicely that looks, is just 2 times 1, which is 2. There's the back, that's the exact same side. The right side here is a 1 times 1. The left side is also a 1 times 1. The top, if you look at it, is also 2 times 1, so it's 2. And the bottom is also 2. So the minimum amount of wrapping paper needed, that barring everything gets covered exactly perfect, is 2, 4, 6, 8, 10 square feet of wrapping paper. I wonder what kind they'll use. Makes no difference, does it? All right, well, let's change the colors because I'm tired of these colors. Number 12, a tether ball on the end of a 7-foot rope swings around the pole. So basically you have this, here's your pole, and there's a ball at the end of the rope, and it goes around in a big circle. So that is just the distance the tether ball travels. They are just asking you for the circumference of the circle with that 7-foot rope radius. All right, so, and look, they actually can have you do that, but if you put down the formula, circumference equals pi times diameter. Well, the diameter is 14, and pi is close to 3, so you just have to get close here. 3 times 14 is 42, so which of these is closest to 42, I ask you? Looks like the letter C. The rest of those are a little ways out there. So the book was pretty nice in that they didn't make you figure it all out completely. Problem 13, there are 2 blue socks and 1 gray sock in a drawer. Ooh, 2 blue and 1 gray sock in a drawer. Without looking, Juan takes 2 socks out. Find the sample space for the experiment using B1, B2, B3. Okay, so on his first pick, Juan can pull out a blue 1 a blue 2, or a green. On his second pick, and we'll make a little tree diagram out of that. If he picked out a blue 1, he could then pick out a blue 2 or a green after that. Here, he already picked out the blue 2, so he could pull out a blue 1 and a green. And here, since he pulled out the green, he could either pull out the blue 1 or the blue 2. So your sample space comes from this. You have to write these down. You could pull out a blue 1 and a blue 2, or you could pull out a blue 1 and a green. That's this tree part. If you start pulling out a blue 2 first, you could pull out the blue 2 with the blue 1, or you could pull out the blue 2 with the green. If you pulled out the green first, you could get the green and the blue 1, or you get the green and the blue 2. This is your sample space. These are your 6 combinations you could get if you only pulled it out to taking 2. The probability of Juan pulling out 2 blues would be this one and this one. 2 out of those 6 times, which is 1/3. It's a 1/3 probability of picking that blue sock. Another way you could have done that, I mean, it doesn't give you the sample space, but if you're pulling out the blue sock, the probability of pulling the blue sock out first, yeah, well, it's the sample space would be the easiest way. It gets a little more complicated if we draw it out there. Problem 14, it is an equation, and remember, to solve equations, we just think opposites. So if I have this, 0.05x minus 0.3 equals 0.2, I'm doing the opposite. Opposite of this is adding 0.3. If I add 0.3, I get 0.5. And now I'm left with this. The opposite of multiplication, which this is I need to divide by 0.5. Divide by 0.05. That gets a little complicated, kids. It's the top being divided by the bottom, which is 0.05. You need to move the decimal 2 places here, moving the decimal 2 places there, which means you add a 0. It's like dividing 5 into 50. The decimal's way over here. It's going to give you a 10. So x equals 10. X equals 10. 15, ladies and gentlemen. It's just this easy. Maybe it helps you to write all this out. You know, you have 12. You have 2 W's on top. You have 3 X's on top and a Y. And then on bottom, you have a 6, 1 W, 2 X's, and a Y. And remember, same factors on top cross off the same factors on bottom. First of all, 6 goes into 12 twice. One of these W's cross off with 1 W on bottom. You've got 3 X's on top and 2 on the bottom. Cross off 1 X for 1 X. You're left with an X. And the Y's cross off. So you're left with just a 2 on top and a W and an X. 2WX is your whole simplified all the way down as much as you can do. Number 16, notice there's no equal sign, so you are just combining and adding like terms. They have to have the same letters. You have 3 X's and you take 1 X away. That gives you 2X. You have 3 and you take 1 away. That gives you a 2. 2X plus 2. Just don't get no easier than that. Problem 17. Oh, look at this order of operations. Remember order of PEMDAS? Parentheses, exponents, multiplication, division, addition, subtraction. So parentheses first. There really is nothing to do in parentheses, but we do have an exponent. And if you go back in your notes, how do we fix a negative exponent? We don't like them. They make us sad. you just flip it over and change it to a positive exponent. So 3/4 is 4/3. Is 4/3. And then remember, we have to do multiplication first. So these two get multiplied together. We can do some cross canceling. I'm left with 4/5 for this part. And look, it is 4/5 minus 4/5. Lucky day. I get nothing. You could probably figure that one out on your own. Oh, problem number 18. Scientific notation and division. Now remember, the rule of this is you divide the left side. So I need to divide 3 into 7.5. Bring up my decimal, it's 2.5 times 10. Now here's the tricky part, boys and girls. With the division, you subtract exponents. I subtract exponents, so be careful with this. Watch. The top exponent, I believe that's an 8. It's a 6, it's my bad. I am then subtracting a -3. And if you look at your rules of integers on subtracting, to subtract an integer, you actually add its opposite. So this becomes adding a +3. So -8 plus a +3 is a -5. Is a -5. 19, you can't really simplify the -5, it stays -5, but here, 2 negatives times themselves gives you a positive, so this becomes +6, and this is -1. So what happens here is this. Think about this, you have like 5 negatives, and then you have 6 positives. Negative and a positive cross off. The difference is this, you have 1 more of these, so you have a +1. You put these two together, -1 gives you again nothing. You get 0, zip, zilch. And finally, at the end, children, the last one here, 1.2 plus 2.24 divided by this. Now let's do this first. Be careful with this. I see kids make mistakes all the time on this. 0.2 times 0.2, again, we're doing that, is 4, but there's 2 decimals, so it's actually 0.04 with the decimal in it. And I have to add those two together, 1.2 plus 0.24. I get 1.44 divided by 0.04. Let's write that out, 1.44 divided by 0.04. Move the decimal 2 places, decimal 2 places, decimal goes here. 4 goes into 14 3 times, which is 12. And 4 goes into 24 6 times. So when all the smoke clears, I get 36. And whew, that was quite an entertaining exhibition. 7th grade. This is a pretty tough test. But if you study, I'm pretty sure you can do well. We'll see how that works. I am going to shut down the phone here. And stop the recording. If you have some questions, you can always ask me before the test tomorrow. Thanks for listening.